So then moving into the next level of making standards, let's talk about the content information itself. What rules can we make about those? And here I'll start with a kind of caution that a lot of people, when they talk about rules for quality control, it might not be explicit, but implicitly there's a lot of talk about digitization workflows. And then, especially if they're not, if it's only implicit, if they're not explicit about it, then those ideas about digitization then get kind of unfortunately applied to other kinds of digital collections where they don't make as much sense. So I want to draw out here the fact that like digitization is different from other digital collections in two ways. Number one, it is one of the very few workflows in cultural heritage where we are commissioning the actual creation of the object itself. And since we are commissioning it, it makes a lot of sense for us to have opinions about what exactly we are getting, because we have control over the manufacturing process, whether it's doing the digitization work ourselves or paying somebody else to do it. So that's very rare. It's why we talk so much about what these things should look like. But it's not the case with other kinds of digital collection workflows. The other thing is that still, for most cultural heritage organizations, digitization work is the bulk of digital collection work. Like most of their digital collections are going to be the output of digitization projects. So that logic of what a digital collection project looks like starts to become kind of overrun with the logic of what a digitization project looks like. And they're not necessarily going to be the same thing. And it's something to be on the lookout for of like, are we falsely applying logic just because we do it all the time for this thing? Does it actually apply for this slightly different thing? That being said, I'm going to spend most of this time on digitized collections myself. But at the end, I'm going to return to the idea of like, when do we ignore this stuff? So when you're asking someone to make a file, what can you require? The first thing that people generally talk about is a file format, because different file formats have different characteristics. You want to choose a file format that best supports the things that you want. You also want to choose a file format that will remain accessible over time, not a technology that might be abandoned or forgotten in a few years. The good thing is that many people have thought about these issues, and there are good standard options for almost any kind of digitization work. I have here on this table those options divided between the sort of like ideas, the recommendations that you've heard for over a decade, or maybe 2 or 3 decades at this point, and then the options that are being promoted in the past 5 to 10 years. So for images, you have TIFF and JPEG 2000. For MOV, or for video, you have MOV or MXF or MKV. For audio, you have WAV or FLAC. For film, you could also use MKV or MXF. You could use DPX. That's a very common standard and a more traditional standard. But those things are just one choice. Beyond the file format, you're going to have to specify how the information is actually encoded. Now, many media formats can actually encode many different kinds of information at the same time that are supposed to be played back at the same time. And they can even support different kinds of data encodings of the same kind of data. These things are known as codecs. So each one of those choices are better or worse for a given purpose. So you have things like WAV and MOV are wrappers, they are file formats, but within that file format, you can use a codec like PCM for audio, or FFV1 for video, or V210 is another video codec. And so, yeah, it gets complex, and then you can actually have multiple kinds of that information in a single file. So for example, think of a video file with multiple audio tracks or subtitle tracks. All of that stuff is all stored in the same file, and each one of those chunks of information is encoded according to a different kind of codec. So it gets kind of confusing, but to zoom back out a little bit, what I want to think about when we're talking about encodings are three kind of rough categories: uncompressed, losslessly compressed, and lossy compressed. All right, so what are these things? Number one, we have uncompressed. Uncompressed is just like the text encodings that we were talking about in text files. With an uncompressed file, each set of bytes that you're looking at can be directly translated to a piece of information, like a character, a pixel, an audio sample, whatever it is, whatever kind of file you're trying to encode there. But that means that if you have something like a 5 megapixel image or an image with 5 million pixels, and you're storing the color information for each pixel with 3 bytes and you're using an uncompressed encoding, you would have 3 bytes times 5 million pixels, 15 megabytes for the storage of that single image. Now, for many years, uncompressed codecs were believed to be the best kind of things that you could use for digitization because it's very simple and so it's very robust. If you lose 1 byte, you're only losing a single character, a single pixel. It doesn't really matter that much. However, as you start to digitize more and more stuff, you start to worry less about losing a single byte and you start to worry more about paying your storage bill, really. It would be nice to store the same amount of information in smaller files and so cut your storage bill. So we have experience with things like zip files. Magically, you put something in a zip folder and it is smaller until you want to unzip it, and then that file is big again. So what zip is actually an example of lossless compression. And what lossless compression does is it takes a set of data, finds patterns within that data, and then encodes the information using those patterns in a way that it uses less data overall, but retains all of the information. So a good analogy for this is acronyms. So rather than saying a long phrase like New York Public Library, I can say 4 letters, NYPL. And as long as both of us agree that how I encoded that information and how you decode that information is the same, I save time talking, you save time listening, everybody feels great. No information is lost. It does open us up to one major problem. That is, if you do lose some of the encoded data, it has much bigger impacts on the decoding of the data. So if I forget to say the letter L at the end of NYPL and I just say NYP, you're not exactly sure what I'm talking about anymore. That does sound bad until you remember that within digital collections, our first line of defense is having copies of file. So if 1 byte of a file goes bad, well, we should have a good copy of all of the bytes of the file somewhere else, hopefully multiple copies. So worrying about this like 1 byte problem is failing to see the forest for the trees. And so here as an example of how does this actually work, how do we apply compression, you know, typically we actually start with an uncompressed encoding of something and then you send it through a piece of software that applies that algorithm to it and compresses it down to a smaller file, and then you put that smaller data stream inside of your wrapper, inside of your file in the end. So the example here is taking a picture of something, it produces RGB data. That RGB data is then compressed using, we'll say, the LZW algorithm or maybe the zip algorithm, and then you put that data inside of your TIFF file at the end. And the benefits of lossless compression can be very, very big, anywhere from file savings of 30 to 80%. And so storage bills slashed by 30 to 80% compared to the uncompressed version. So that's really huge, and it's something that I think is worth considering. The final kind of encoding to think about is lossy compression. So lossy, as the name implies, actually loses information, but it does so for a very good reason. It allows us to make those files even smaller in order to make it easier to send them over the internet or store them on our computers or do whatever we want to do, like actually use the files. And these are encodings in files that you are most familiar with, like JPEG, MP4, MP3. Those are all lossy standards because it's more important for us to have like a smaller portable object than it is for us to have the most perfect representation of the data that we had before. We are actually throwing information away in order to have this portability factor. So you probably don't want to digitize to something like a lossy encoding, but you may want to create a lossy version of your files so that you can provide them for access purposes so other people can have portability. So Yeah, there are lots of good options here. The codecs are, again, something that people have talked about for quite some time, and you can find good guides for these kinds of things. But even once you choose the encoding, you still have to pick more details. You have to say, what resolution do I want for my object, the color bit depth, the audio bit depth, the frame rate, all of these different things. The more data that you spend on these decisions, the more closely, the more perfectly your digitized file will represent the digitized object. However, your files will grow in terms of file size. So it is something that you want to keep in mind. But again, maybe you don't want to be an expert in this stuff. I mean, none of us really are. And more valuable to consult guides that we've published, like the Federal Agency Digitization Guidelines Initiative, also known as FADGI, which will help you tell what do you want to do. But again, keep in mind the fact that like as you're choosing all of these things, one of the big things that happens at the very end is that everything that you do does impact the size of your file, which means the long-term storage costs of storing that file. But everything I just said for digitization sometimes applies to other kinds of digital collections, sometimes not. So, for example, if you have like a Born Digital Oral History project, you may want to define the file formats. You may even want to define the encodings, but you may not want to say, we want lossless encoding or we want even uncompressed compression. You may just say, give us a good video file, because that allows you more variety in the equipment that people bring to that project. It also sometimes is just impossible to actually store some of this data. So uncompressed HD video at 2K resolution, 60 frames per second, that's 5.4 terabytes per hour. That is just unsustainable. And so the default in modern video production is actually lossy compression, and that's fine. We're capturing more information than our eyes can see. We can throw some of that information away. Similarly, if you're collecting Born Digital files in an archive, you should just respect the files that you receive. As I said in the beginning, the file that somebody made, they made it for a purpose. And unless you fully understand that purpose and all the choices that you made, it doesn't make sense for you to try and improve their file by converting it to some other kind of format, because you might be somehow combating the original purposes that they had, and you might be performing an act of a preservation instead.